Hi everybody and welcome to this video on the 2020 preliminary paper 1. In this paper we're going to have a look at question 11 on the probability. Once again, please make sure you've attempted this question before watching this video. Let us have a look at the question. So here we're given that A and B are independent events. That's quite an important bit of information. If they tell us events are independent, then we know probability A and B is equal to the probability of A times the probability of B. And then we have some information. I'm just going to draw a Venn diagram to represent some of this information. So we have probability of we have event A, we have B, and the probability of B only is 0.3. So what's happening in this little piece is 0.3. The probability of A and B is 0.2. So this here is 0.2. The probability of A only is X. So that goes there. And then the probability of not A or B, which is the rest, is over there. So what we would like to do is solve for X and Y. There are two unknowns, so we're going to have to get two equations. Now, the first equation can come from the fact that they are independent. So we have that the probability of A and B is equal to the probability of A times the probability of B. And this is due to the independence. So now the probability of A and B is 0.2. The probability of A is everything that's in A, so it is X plus 0.2, and the probability of B is everything that's in B, which is 0.5, the 0.3 plus the 0.2. There we have now an equation which we can solve. The first thing is we're going to divide both sides by the 0.5, so we're going to get 0.4 is equal to X plus 0.2, and then minusing 0.2 on both sides, we get that X is 0.2. Now we can get Y. How will we get Y? We'll use the fact that when we add all of these probabilities, we'll get 1. So probability of A or B plus the probability of not A or B is equal to 1. So A or B is everything that is in the Venn diagram. So it's everything that goes over there. So it's the X, which was 0.2, plus the A and B, which is 0.2, plus the B only, plus the A and not B, the not A or B, which is the Y, and that's equal to 1. So what we have is 0.7 plus Y is equal to 1. So then solving for Y, we get Y is 0.3. I hope that you've understood this question. Let us move on to the next one. So it says 6 players of a volleyball team stand in random positions in a row before the game begins. X and Y are 2 players in this team. Determine the probability that X and Y will not stand next to each other. Okay, so this here is your counting question, where we have to then calculate the probability that they will not stand next to each other. So let us start. So the first thing we're going to do is we're going to have that there's 6 players. So we think of the different possibilities. Sorry, my pen is jumping. Okay, so it looks like I've sorted out my pen. Sorry about that. So we have that. So we have 6. So we want the probability that they will not stand next to each other. So there's different ways that this could happen. It's easier to calculate the complement and subtract 1. In other words, the probability that they not stand together is equal to 1 minus the probability that they stand together. So it's easier to calculate that they stand together. So the probability that they stand together, okay, to find out the probability that they stand together, what we're going to do is treat them as one person. Okay, so X and Y you treat as one person. So you have 1, 2, 3, 4, 5. So instead of having 6 people to arrange, you have 5. So in the first position, you have 5 ways. In the second position, you have 4 people, 3 people, 2 people, 1 person. So this here is arranging the 5 people where X and Y are considered one person. That way they're always together. But then we're just also going to have to multiply by 2 factorial. And this 2 factorial arranges X and Y. So it accounts for X being first and then Y being first and then X. So this here deals with the order of X and Y, those people. So we're treating X and Y as one person, we're arranging them, and then we're ordering them over the total. So the denominator must be the total number of events, and the total number where you can arrange 6 people is 6 factorial ways. So then this here is equal to 1/3. Okay, so then that means the probability that they're not standing together is 1 minus 1/3, which is 2/3. So sometimes it helps to calculate the complement of the event. Then it says determine how many 4-digit numbers can be formed from 10 digits 0 to 9 if repetition is allowed. So for 11.3.1, we have 10 digits, 2, 3, 4. I mean, is it how many word? 4 digits. Oh, sorry, 4 digits. So we want a 4-digit code. And this time, the first one, repetition is allowed. So we have 10 options for this first one. We're still going to have 10 options for the second one, 10 options for the third one, because we're allowed to repeat it. So it's 10 to the power of 4. For 11.3.2, it says digits are not repeated. So now these 4 units need to be unique. So in the first option, we can use any of the 10 digits. The second digit, we can use any but the one that we've just used, so 9. And then the next one, we can use any of the digits, but not the 2 that we've already used, and so on and so forth. Okay, so that's the one that repetition is allowed. Okay. Repetition is not allowed. And then the last one is that 11.3.3 is that the last digit must be a 0. So we know that we're going to put our 0 there. So there's 1 0, so it's there in the last digit. How many options do we have for the next one? Well, we only have 9 numbers left, and then 8 for that option, and then 7 for that option. So we have, so to calculate the first one, it's 10 times 9 times 8 times 7. So 5040. And the second one is 9 times 8 times 7. 9 times 8 times 7, 504. Okay. Okay, so I hope that you've understood this question. Please watch our other videos on the series, and thank you for watching. Bye.